Okay, so in our first piece of information here, as we work with inequalities, oftentimes it works just like an equation. So you solve it like you're finding the x, getting it by itself, just like you would with an equation, but there just happens to be this inequality symbol. So for example, in this first one, maybe the first step I would do, and I'm going to kind of go through the full thing here, I'm going to minus off 3 from both sides of our problem. And I would end up with 6x on the left greater than 2x plus 8. And so I've moved the numbers to the right-hand side, but now what I'm going to do is I'm going to move the variables to the left, so I'd subtract off 2x from both sides. And I end up with 4x is greater than 8. And then finally, to get the x alone, I would divide both sides by 2. And I end up with this x is greater than 4 as an answer.
Why did you do that?
Oh, I'm sorry. My bad. I apologize. I was thinking ahead to the answer and I divided by the wrong number. Thank you very much. So I would divide by 4, pardon me, and I get x is greater than 2. Thank you. And this is the algebraic solution to this for the inequality x is greater than 2. What it means is if you were graphing this on a number line, you would see back in the day the number 2 on the number line, and you would put a open circle because that 2 value is not included. That's what the greater than means. If it was going to be included, you'd have that little bar underneath that means also equal to. And you would shade the numbers that were greater than 2. And that would be your visual. Today, we're also going to add a new piece of information. We're going to add the symbols using parentheses or brackets. A parentheses means the number is not included. A bracket means it is included. So off to the side here, not included, usually involves a greater. Sorry, whiteboard shenanigans. Not included often involves either a greater than symbol or a less than symbol. Whereas the brackets means it's included, and that will be a greater than or equal to symbol or a less than or equal to symbol. And so you should have those in your notes. So this orange answer that you see here would be written the following way. I start at the number 2, but don't include it for an x value. That's what the parentheses means. Comma, and I keep on going forever. So what you would do is you would put an infinity symbol with another parentheses. And the thing that's really important to understand about that is with infinity symbols, they're always parentheses, whether it's a positive infinity or a negative infinity.
What do you mean always parentheses?
It's always parentheses. You can't put a bracket on an infinity because you can't include it. That is a direction, not a number. Amanda.
So the parentheses and brackets and just a different way of writing
The greater than or less than symbols, yep. It's a different way. The orange stuff and the purple stuff are the same thing, different techniques for writing the same thing. Gabe.
Wait, how do you have a negative?
Well, because if you're going to the left, you're going in the negative direction. I'll show you later. Hang on for that question. Okay, so in the orange is the traditional way. In the purple is the new way. In the black was the traditional way of graphing it, so that was this technique. If I were to graph the purple one using the new way, I would do it like this. I would have a number line. I would put the number 2. I would put a parentheses, and then I would shade. So instead of open circles, they're parentheses now. Instead of solid dots, they're going to be brackets. And that's all that this problem was trying to show you. Open circle, parentheses, solid dot, bracket. Let's try another one. In number 2, Something that's different about this one is there's a fraction and there's a negative sign in front. So as I work through this problem, again, I'm going to move the numbers to the right, so I subtract off 2 from both sides. When I do that, I get negative 3/4 x, or negative 3x over 4, is greater than or equal to negative 5. Because negative 3 minus 2 is negative 5. I don't like that I'm dividing by 4, so I'm going to multiply both sides of the equation by the number 4. The reason I'm doing this is because on the right-hand side, or on the left-hand side, pardon me, the 4's reduce out, and I end up with negative 3x is greater than or equal to negative 20. At this point, I'm going to divide both sides by negative 3. And then something really crazy happens to our inequality symbol.
Flip it.
You have to flip it, very good. So when I divide, I end up with x is less than or equal to, because the symbol flipped. So let's highlight that to show that that happened. I went from greater than or equal to the less than or equal to. And negative 20 divided by negative 3 is positive 20/3. Again, traditionally, what I would write here is I would have a number line. I would put the number 20/3 on there. You don't have to change it. You don't have to write it as a decimal. Because I had a less than or equal to symbol, whenever you see that bar on the bottom, it means that you're going to have a solid dot. And then I'm shading to the left because the arrow is pointing in the left direction. So, or in other words, I'm less than or equal to. So this is what it used to look like. This is something you covered in the past with inequalities. And all we're saying now is we're going to write it a little bit differently. Since the 20/3 is the biggest value that x can ever be, what you would do is you put 20/3 on the right-hand side, and now I would use a bracket to say that I end at 20/3 and I also include that value. But I'm also going all the way to the left, and in the left direction is the negative direction, and I go that direction forever. So that means I have negative infinity, or in other words, I'm going to the left forever. Remembering that if it's an infinity symbol, you can never include it. There is a solid dot there. Or sorry, a parentheses there, not a solid dot, not a bracket. Parentheses, always, always, always for infinity symbols. Parentheses, always for infinity symbols. Yes?
Me?
Yes.
Does it matter that in the first one you did the number and then you...
So if I'm looking at my stuff, something to note, the small number is always on the left, and then comes the big number. Always. Small, then big. Let's try another one. In this next one, the thing that's different is instead of being 2 sides to an inequality, there are 3 parts, a middle, a left, and a right. Don't worry, not a big deal. It's just that you're going to be affecting 3 parts instead of 2 parts when you make your movements. So as I look at number 3, what I notice is in the middle, to get the x alone, what I'm going to need to do is I'm going to need to add 1 to all parts. When I add 1 to all 3 parts, on the left I have negative 6. There's a less than or equal to symbol. There's the 2x now in the middle because the 1's canceled. And there's a less than symbol, and then there's a 10. At this point, the only thing I need to do to get rid of the stuff in front of the x is divide each piece by 2. So as I divide by 2, I end up with negative 3 less than or equal to x, which is less than 5. Now hopefully this thing hits home so that you can see what happens on a picture. Traditionally, on a picture, what I would be doing is I'd be putting the 2 numbers, the one on the left, negative 3, the one on the right, positive 5. Notice how the one on the left has a bar. So that's a solid dot in the old way. And the one on the right has a less than symbol, no bar. That's an open circle. And the x is in between them. So I shade everything in between. if I were to represent this, the same information, in the new style that we're talking about today, you would still have the same two numbers, -3 and 5. You put a comma in between. Since the bar was with the -3, you put a bracket. Since the bar was not with the 5, you put a parentheses. And if you were graphing it, the graph looks almost exactly the same. You have the same two numbers. But now you have a bar with the -3 and a parentheses with the 5, and you shade everything in between. So the solid dot became the bracket, and the open circle became the parentheses. Everything else is pretty much the same thing.
Where do you want us to write it on the test?
If it doesn't tell you on a test, I don't care which way you write it. Okay, so I just want you to be aware that there is that kind of information.
Which one's the older one?
Old, then new.
So you can keep. Might you have a copy of the note packet? I left mine. I left don't move.
So notice that when we did our problems, just to emphasize again, when we multiply or divide by a negative number, that's when we flip the symbols. Otherwise, we do not. When we multiply or divide by a negative number, we flip the symbols. Otherwise, we do not. Number 4 has some kind of weird sentence structure for what we're supposed to do. This problem actually has 2 parts to it. So it says using a graphing utility, we're not going to really do that. What we're going to do is we're just going to solve each inequality algebraically. So let's take a look at this first one, letter A. So if I do letter A first, what this is trying to tell us to do is to say -1 is less than minus 2x plus 4, which is less than or equal to 5. And all they're telling you here, which seems kind of a difficult way to do it, is this y stuff right here. Substitute what they told you y was. And you're just going to shove that in wherever you see the y. So that's this stuff right here. So they said, hey, y is -2x plus 4. And letter A says, shove that in between -1 and 5. That's it. And now we do the problem. So in order to do this problem, I'm going to subtract 4 off of both sides. And hopefully this problem will show us a little bit about the changing the symbol again. So here I have -5 is less than -2x, which is less than or equal to 1. At this point, there's only a -2 in front of the x. So what I want to do is I want to get rid of that -2, and the way I would do that is I would divide by -2 everywhere. When I do this, I get 5/2, or 2.5 if you wish, is less than x, which is less than or equal to -1/2. And here's where you have to be very cautious, because you did all the math right, you flipped the symbols right, you divided by the negative number, you did everything right, but something's really goofy about this mathematical expression here with inequalities. What's goofy is the negative is on the right and the positive is on the left. This is not correct. You can't write it that way. The small always has to be on the left. So what I'm going to do is I'm going to pinwheel it. I'm going to spin it around.
You flip the side.
Yeah, you.
Oh, did I forget to flip the signs? Thank you. Sorry. Thank you very much. Remember, sometimes I forget. Thank you. So this is now a greater than, and this is a greater than or equal to. I apologize. Thank you. So still, the negative is on the right, and the positive is on the left. That's not okay. Smaller numbers are always to the left, so I'm going to spin it. Here's what it looks like when you spin it. The -1/2 must be on the left. The positive 5/2 must be on the right. The x is still in the middle. Notice that the opening for the 5/2 went towards the 5/2. You guys see that? How the mouth is eating the 5/2? The mouth still has to be eating the 5/2. So I make the mouth eating the 5/2. Gobble, gobble with the 5/2, gobble, gobble with the 5/2. On the 1/2, which is negative, and the x, the mouth is actually eating the x. So I'm going to make the mouth eating the x. And your symbols should be in the same direction when you do this. So they were both pointing to the right originally, and now they're both pointing to the left when I pinwheel it. I just want you to make sure that you do it this way so that when you graph this thing, you get it right on the exam. Okay, so don't leave the smaller number on the right. The smaller always goes on the left. At this point, it's the same as all of our other problems. I just graph it. If I'm going to graph it, it would look like this. I would put the negative 1/2 somewhere on the left. I'd put the 5/2 somewhere on the right. Traditionally, I'd put a solid dot with the negative 1/2 and the open circle, and I would shade everything in between because it's all the numbers that are in between that. If I were going to do this in the non-traditional way, the new way that we've been talking about, what I would do is I would rewrite this information as negative 1/2 with a bracket, because there was a bar, comma, 5/2 with a parentheses, because there was no bar. And then if I graphed it, I would just use those symbols instead of the dot and the open circle. So I have the negative 1/2 still, I have the 5/2 still, but this time there's a bar, or a bracket I should say, excuse me, a bracket with the negative 1/2 and a parentheses with the 5/2. And so it works exactly the same, just different symbols. Okay, so this is like our previous problem. The big thing that happened though is that when I divided by that negative, the numbers were in the incorrect places. I had to readjust. Part B is saying go back to that same purple circle in the beginning, the negative 2x plus 4, and this time shove it in again and start all over. So as I do that, here's what happens. I have negative 2x plus 4 less than or equal to 0. Here is that same information that came from here, which was the y value. And I'm now putting it in for the less than or equal to 0 part of the problem. These are two separate problems. At this point, I'm going to add 4 to both sides, subtract 4 from both sides. And I have negative 2x is less than or equal to negative 4. And then again, to get rid of that negative symbol, I'm going to divide by negative 2. And my symbol flips. So I have x is greater than or equal to positive 2. And when I graph it, I don't have any issues about worrying about stuff. I just put the number on there, and it's a solid dot, and I'm going to the right. I'm not going to put the new symbols on there. You can figure that out. Bracket to the right. Okay. If I were writing it in the new method, though, I would write it like this: 2 comma infinity, and the 2 would have a bracket, and the infinity always has a parentheses. Always. So in our last two problems here, we're dealing with absolute values. And I'm going to teach you how to set them up. And once you set them up, they're like any other inequality problem that we've done so far, the first 4 or 5 things that we've done. Whenever you see an absolute value problem, number one, and most importantly, always make sure that the absolute value is on the left. And write that down. Absolute value has to be on the left. So if they would have had like the 4 less than absolute value thing, pinwheel it so that your absolute value is on the left. Super important. Second, question's going to have to wait, sorry. Second, whenever you see something with a less than symbol, that's this symbol here, or a less than or equal to. So if the point is towards the absolute value, you will always, always, always set up your problem this way. This problem is set up with the stuff inside the absolute value in between the two numbers, 4 and 4. Except the one on the left is going to be negative. So take the stuff inside and put it in between the two numbers that you see, the number that you see. The one on the left will be a negative, the one on the right is a positive. There's the absolute value junk. And now I've added the negative 4 on the left side. Questions about that? I'm at it.
So when you begin with, it has to be on the left side, not as you're going.
When you begin, the absolute value must be on the left to start. If that happens, take the stuff inside, put it in between the number on the right that you see and its opposite on the left. Always. Now this is a problem that we've done many, many times. So I can just go -3, -3, -3, and then I get -7 on the left, less than x, less than 1. If I graph this in the traditional means, I put that -7 down, I put the 1 down, and then I have the open circles and everything in between. This is always the way that you'll do it. If you see this less than symbol or a less than or equal to symbol, you'll always have something shaded in between. On the other hand, if you see something like letter B, with the absolute value on the left, of course, this actually has two separate problems. So whether it is a symbol like greater than or equal to, or it's just the greater than symbol, either one, if you're using the word greater anywhere in there, then you always, always, always start out this way. You will write down what you see without absolute value. So 2x plus 4 greater than or equal to 6. You will write down the word or, and then you'll have what you see inside. Flip the symbol, change the sign. Flip the symbol, change the sign. So it was greater than or equal to, now it's less than or equal to. It was +6, now it's -6. So anytime there's a greater than or equal to or a greater than, write down the stuff, greater than or equal to what you see, and then with an or, write down the stuff, flip the symbol, change the sign. Solve each one of those separately. So the one on the left. First thing I do is I subtract 4 from both sides. When I subtract 4, I get 2x greater than or equal to 2. Divide both sides by 2. X greater than or equal to 1. Don't forget there's a word or that's happening all the way along.
You don't flip the signs? Or the...
Look at the board. In the next part, I'm going to subtract 4 off. Again, I get 2x. This time it's less than or equal to, and a -10. Divide both sides by 2. And the second part of my inequality is x less than or equal to -5. The reason you have to do it this way is because when you do your number line, here's what ends up happening. So we have the old school way of answering the inequality. It's x is greater than or equal to 1, or x is less than or equal to -5. When I put my number line down, no, I don't want that color, sorry. When I put my number line down, here is what's going on. Which number is smaller, 1 or -5? -5. So -5 goes on the left of the number line. 1 goes on the right side, because the small numbers are always on the left. In the orange, it says x is greater than or equal to +1. So that means I have a solid dot on the +1, and I want all the numbers that are greater than or equal to that, which means this. The pink says x is less than or equal to -5. So I have a solid dot on the -5, and I want all ones that are less than or equal to -5. Now here's one where I want to talk a little bit about the symbols that you would use that are the new symbols. If I'm doing the new symbols Actually, I'm going to do the new graph first, and then I'll do the new symbols. The new graph is pretty simple because all you're doing there is you're putting down the same numbers, -5 and 1. And this time, what you're going to do is you're going to use brackets instead of solid dots. So that's not really that big of a deal or that big of a change compared to what you're used to. But the symbols, on the other hand, are kind of a big deal. So here's how it works, and it's kind of mind-blowing a little bit. So pay close attention and then ask me your questions. The pink stuff. What's to the far left of the pink? What's the smallest thing it is? Negative infinity. Remember, it's never a bracket, so it's negative infinity, and it stops at -5. And because the -5 is included, whatever symbol you see in the new way, you put down. So kind of the nice thing about the new way is you can see the bracket, and that's what you use again. So I kind of like that about the new stuff. In the orange, notice how the smallest thing in that section of my graph is a 1. That's where I start. So I put a bracket and I write down a 1. And then it keeps on going forever in the positive direction. That's an infinity. Remember, infinity is not a number, it's a direction. You're going in the positive forever. Now the thing is, oftentimes with ordered pairs or these, what we call intervals, we use commas. But when we have two sets of intervals, they use a symbol called the union symbol. It looks like this. Kind of looks like a U. It's a parabola looking kind of thing. So the only thing that you have to do is if you're doing interval notation. Interval notation. And the stuff is split. Then you have to have the union symbol to symbolize that you have a split.